Okay, let us go ahead and get rolling to the 2002 question B and C. So we read the question real quick. A container has the shape of an open right circular cone. The height of the container is 10 centimeters and diameter is opening is 10 centimeters. Water in the container is evaporating. So its depth H is changing at a constant rate here. So right away, I think for me, this lets us know the rate of change. The height is decreasing, it's evaporating. So this water is getting smaller and smaller in this cone. So we know dH dt has to be -3/10. So we know that dH over dt has to be -3/10 centimeters per hour. Now, they could have told us decreasing at 3/10 centimeters per hour, and then you need to put the negative symbol. They were nice enough to give us a negative symbol, but that's something to be mindful of with the language. So let's go to part B. Find the rate of change of the volume of the water in the container. Okay, I'm gonna pause for a moment with respect to time. What we want is dV over dt. So we know we need to take the derivative of the volume of this object when H equals 5 centimeters. Take a look at the picture. Do we have the volume of this cone? Well, great news. They gave it to us. They gave it to us right here. So we know, okay, we need to take the derivative of this. So let me write it up here for a moment. V is equal to 1/3 pi r squared times H. We're going to take the derivative of this, okay? And I want you to just think about how we could go about doing this. One, I could do the product rule, because we got to take the derivative with respect to time. There's no t variables, so everything is going to have what we call implicit differentiation. So I would probably label this to be my first, and then I will label this to be my second and do the product rule. I don't like this, and this is the reason why. Do I know what dr dt is? Well, if I look around right now and read the problems, nothing in here tells me what dr dt is. Nobody is telling me how this radius is changing. That's a bit of an issue because we would like to have that to use the product rule. So then the next best thing to do is go say, okay, here's the thing. We know what dH dt is, right here when we go to take our implicit derivative, but we do not know, again, what R is. So then my job is to go, cool, I want to make this process as smooth as possible. So now here's what I got to ask myself. Do I have a relationship between the radius and the height? Well, here's the good news. We're given the radius up here, right? The radius is half of this length up here, and we're given the height here. So we know for a fact, if we look over here, we know the rate of change of the radius with respect to time when H equals 5. We have kind of a relationship we can use. So how do we go ahead and do this? Well, we're going to do R divided by H. Now, I could do H divided by R, but here's the reason why I don't want this. I'll show it to you in a second. Okay? Well, we know when the height is 10, so I was going to go on the bottom because that's where the height is at. The radius, well, luckily for us, over here, it tells us that this is, if you look, 10, so the radius has to be 5. So now we know R over H is equal to 5/10. Now, not 5/10, I meant to put 1/2, just to simplify it a bit. Now, what do I want to do? Well, hopefully this will all make sense here in a second. I want to multiply H to both sides, like this. So what I'm going to get is these cancel. I'm going to write it down over here. Let me get rid of this now. And I'm going to write R is equal to 1/2 H, like this. Now, this is why I wanted the R on the top and not the H on the bottom. Over here, if I multiply R to both sides, right, I get H is equal to, and then I have to move stuff over. I don't want that. I wanted the radius on the numerator because that's what I want. I want radius in terms of height. So this is a little equation that's going to help me now solve this, because now I can take this here and I can plug it in to the R. So if I do that, this is what my volume will be. V is equal to 1/3. So all I did was rewrite this, but take what my radius was in terms of height, and I plugged it into R, and I get this. So I'm going to give the volume is equal to pi over 3. I'm just going to put it together like in one fraction. 1 squared is 1. 2 squared is 4, so this becomes 4. This is H squared times H. Now if I go to rewrite this, this is what I'm going to get. So now I'm going to get pi over 12, because 3 times 4 is 12, and then these become h to the third. Now that I have everything with respect to h, now I can take the derivative of this, and this would be preferred. Again, the reason why this is preferred for me is because we did not know what drdt was. If I had known what drdt was, I would have just probably used the product rule, because I don't know, I probably would find that to be a lot more manageable. But nonetheless, this is probably the best way to go about it. Now let's take our derivative of this. Let me go ahead and just clear this out. dv over dt is going to equal pi over 12. And if you remember, it's been a while, I like to put a set of parentheses around the h. I'm going to use basically the power rule, bring the 3 down. So I'm going to get 3h squared, and then the derivative of h, remember this is implicit, is dh over dt. Once I got that here, I'm going to simplify this, right? 3 and the 12, these are going to cancel out, and I'm going to get 4. Or you could do 12 divided by 3 is 4, but because the 12 is bigger, that's going to become pi over 4 h squared dh over dt. And then here's the beautiful part. I can finally figure out what the volume, the rate of change derivative, the rate of change of the volume, by plugging in 5 for h and plugging in negative 3 over 10 for dt, this dh over dt. So I'm going to get pi over 4, 5 squared times negative 3 over 10. And I could technically leave it like this as long as I include units of measure. We know dv has to be centimeters to the third power divided by time, which is with respect to time. So with respect to, I believe in this problem is hours. So hours. If I wanted to do this, by the way, it'd be a little bit annoying, but 5 squared is 25. 25 times negative 3 is negative 75. So negative 75 pi over, and then 4 times 10 is 40. Hopefully I did the math there correctly. I think I did. Anyways, there it is. And we get ourselves our expression right spanking here. So there it is. Hopefully this one makes sense. Hopefully maybe a little bit better than just looking at the answer key. Let's go ahead and go to part C. Show that the rate of change of the volume of the water in the container due to evaporation is directly proportional to the exposed surface of the area of water. So basically what they're saying is this. Let's just take a moment to figure this out. And then it says, what is the constant of proportionality? Well, here's what I want you to know about proportionality. It's saying that if something increases, like, let me just explain it with the picture, okay? This is what it's basically saying. That the rate of change of the volume of the water due to evaporation, that means as this water is evaporated, it is directly proportional to the exposed surface area of the water. I'm basically telling you, if this volume of this water is decreasing, the surface area of this cone, the surface area right here, the surface area of this cone is also going to decrease. They're proportional to each other. If the rate of change of the volume decreases, then the area of the surface area has to decrease as well. That's what proportional means, that they're directly connected to each other. If one increases, if dv dt increases, then increases or decreases. If this increases, well then so does the area of the water should also increase. If it decreases, it's also going to decrease. That's what it means by proportionality. Now, when it says what is the constant of proportionality, we haven't really covered this in a long time, or we didn't actually cover this. We were going to, but all that means is, for example, like if my monthly, my monthly bank account is directly proportional, equal to my paychecks, my income. Well, in any problem, this number in front here that would usually go here is my constant of proportionality. That's basically like kind of connects both of these together. So now in my case, this could be how much I make per hour, right? My monthly income, my monthly bank account is directly proportional to my income, and my constant is technically like how much I'm getting paid every hour. Here, the constant is, well, there's some constant that's telling us the relationship between these two. As one decreases, the other one decreases. Well, here's the good news. Show that the rate of change of the volume of the water, so rate of change of the volume, we already got that. dv over dt is equal to, we literally got this already, pi over 4 h to the power of 3 dH over dt. Now, it says it wants to be directly proportional, so technically you want this equal to some constant of proportionality. So this is going to be some constant. I'll put A for now, times the area of a circle. So we need to figure out what is the area, like what is the relationship between these two. Well, what we need to do is we need to transform this into this somehow. Well, how do we try to do that? Well, we do know what dH dt is. So if I write over here, I know pi over 4 h to the third. This is negative 3 over 10. We know that already. We want this to look like this right here. And this is, by the way, this should be a 2. So we want this to look like this, right? Well, here's the good news. We have the pi's. There's the pi's right there. Instead of h, what do we want? Well, instead of the h, we want r. Well, remember, we have a relationship. R is equal to 1/2 h, like this. Well, I want to substitute something in for h. So let me multiply 2 to both sides now, kind of going backwards. And these cancel, and I get 2r is equal to h, just kind of like what you normally would expect, right? 2 radiuses is equal to your height. So nonetheless, let's plug it in. Pi over 4. This is going to become 2r squared negative 3 over 10. Okay. 2 squared is 4. And then this is r squared. Since 2 squared is 4, they're going to cancel out with this right here. And we're going to get pi r squared times negative 3 over 10. Now check this out. We've slowly manipulated our rate of change of the volume to start to look like the area model. We have pi r squared, and then right here, the number in front is my constant of proportionality. It's what connects the two. Well, what's connecting the two together is this negative 3 over 10. So now I know my constant of proportionality is negative 3 over 10, which makes sense because this is technically the rate that water is evaporating, the depth of the height. And as the height decreases, the volume decreases, which thus the surface area decreases. So technically, even though this is the proper way of going about it, this is our constant of proportionality. This is our A right here. This is the number that was in front of right there. So hopefully that makes sense. Still a little bit tough. Let me know if there's any more parts you need help on.